Hello, welcome to Math with Mr. Dobrescu, to the rescue. Today we are going to do a proof of the Pythagorean Theorem. The Pythagorean Theorem is telling us that in a right triangle, the square of the hypotenuse, or the side opposite of the right angle, this is the right angle, and the side opposite the right angle is called the hypotenuse, okay, is equal to the sum of the squares of the other two sides. In other words, in a right triangle with legs A and B, the first leg, which is the smaller leg, we call that A. The bigger leg, we call it B. So A squared plus B squared, okay, equals C squared, okay. So this is called the Pythagorean Theorem. So today we are going to prove it. We are going to come up with this answer by proving it. Let's take a look at an example here. So I'm going to create 4 identical triangles, right triangles. I did my best. It's not to the scale, but just pretend that all of these 4 are identical triangles. And each triangle has this side, we call that A, this small leg, we call this A, and the bigger leg, or the other side, we call it B. And we also have the hypotenuse, which is C. Each of these 4 triangles have the same information. And let's continue now. And now we are going to put all those 4 triangles together to form a square. So if we put all of those 4 triangles, triangle 1, triangle 2, triangle 3, and triangle 4, from the other slide, we put them all together and create a square. We create a square A, B, C, and D. And if you look more carefully, we can see that inside of this big square, we see another square. E, F, G, H. Another square has been created. And now we're going to prove it. We are going to prove it that we are going to find first the area of square A, B, C, D. A, B, C, D. Okay, we are going to find the area of that square. And remember, this little side we call it A, and the other leg we call it B, right? We have A and B, A and B, A and B, and A and B. And now we know that the area of a square is side squared. And each side of this is A plus B. A plus B makes one side. And because we got to square it, the area of the square ABCD equals A plus B squared. Okay, that's the area of the big square. Now, we are going to find the area of these little 4 triangles. And remember, the area of a triangle is 1/2 base times height. So in this case, the base is A, the height is B. So it's going to be 1/2 times AB. And because all the triangles are the same, every one of these triangles are going to have the same area. 1/2 times AB. The same here, 1/2, 1/2 times AB. And the same here, 1/2 times AB. So now the area of 4 of these triangles, all of these 4 together, is 4 times 1/2 times AB. It only makes sense. Okay? And if we simplify now, we can simplify 4 and 2. 4 divided by 2 is 2. And that's a 1. And now we can multiply 2 times AB, and this becomes 2AB. So the area of the 4 triangles, this triangle, this triangle, and this triangle together, the area of all of those 4 triangles together is 2AB. And remember, the area of the big square is A plus B squared. And now we are left over with the area of this square right there inside of the bigger square. But this square has the side C. Therefore, the area is C squared. Okay? So the area of square EFGH equals C squared. So now we have all the areas together, right? So now let's equal all the areas. So now we have area of the ABCD, the bigger square, should equal the area of all those four triangles plus the area of this square inside, right? So the area of EFGH, the area of this square, plus the area of all those four triangles. And now we are going to substitute. Let's substitute the area of ABCD. So instead of area of ABCD, we got it. We're going to put A plus B squared. So let's write that down. We're going to have A plus B squared equals, now the area of EFGH, the area EFGH, this area was C squared, so equals C squared, and plus the area of all the triangles, which is 2AB. 2AB, and let's continue to see what we get now. So far so good, right? So the area of the bigger square equals the area of this square plus the area of all the four triangles. And now A plus B squared means A plus B times A plus B. We multiply it twice. So let's multiply. A plus B times A plus B equals C squared plus 2AB. And now we are going to multiply by the FOIL method. We multiply these two and then plus this, the inside and the outside. So we get A times A becomes A squared. So we have A squared plus A squared plus AB, and then plus BA, and then plus B squared equals C squared plus 2AB. And now if we look carefully here, we can see that AB and AB becomes 2AB. Okay, so let's write all of this here. So now we have A squared plus 2AB, if we combine those two together, plus 2AB plus B squared equals C squared plus 2AB. And now if we subtract 2AB from both sides, we are going to end up with the Pythagorean theorem. Let's subtract 2AB from both sides. Minus 2AB. And now this will cancel, this cancels out. So now we are left over with the Pythagorean theorem. A squared, we have here A squared plus B squared equals C squared. So we got it right there. Okay? After we substituted all of this, we ended up with A squared plus B squared equals C squared, and we were able to do a proof of the Pythagorean theorem. So this is right here. A squared plus B squared equals C squared, right? This is the small leg, the smaller leg, and then the larger leg. And this was the hypotenuse. Okay, right here. A squared plus B squared equals C squared. We got it. We proved the Pythagorean theorem. About a few years ago, I was so happy to travel all the way to the island of Samos, the island where Pythagoras was born, and I actually saw the drawing of one of these triangles. It was a statue looking something just like that. And I was swimming right there. There was a nice, beautiful beach. And I was swimming there and looking and adoring the statue created by Pythagoras. A beautiful city where he was born. And I was so happy because now, today, I'm having the chance to do a proof of the Pythagorean theorem. And there are many other proofs you can do, many other ways to prove the Pythagorean theorem. And if you do it another way, please write it in the comments. But again, I'm so happy that we were able to prove it today. A squared plus b squared equals c squared. And thank you so much for watching. And I appreciate you subscribing and sharing this video. And please stay tuned for our next video. All the best to you.